Suppose we have to multiply 2 times 3. Then you'll say that that's very simple. 2 times 3 is actually 6. And if we have to multiply 0 times 1, it will be actually 0. And 10 times 10, you will say that that's actually 100. That's really very simple. But what if you are given multiplication of 0.1 times 0.1 or 0.2 multiplied by 0.3. Now you can clearly see that these two numbers, this is decimal, this is decimal, this is decimal number, and this is also decimal number. So the point is that how will we multiply when we have to deal with decimal multiplication? How will we perform it? Well, let's take this first one. This video tutorial is about the theoretical portion of this one, that why we do what we do. Okay, so if this is first one, let's take 0.1 multiplied by 0.1. Okay, now we know that 0.1 is actually what? 0.1, that is decimal point and 1. It means that we know that the first place to the right of this decimal point is always tens, right? This is tens. We know this. Therefore, this 0.1 can be written as 1 over 10, right? This is a very basic, concept which we learned in decimals. So this 0.1, since 1 represents is at a tens place, therefore we can write it as 1 over 10, right? It means that this 0.1 can be written as 1 over 10. This 0.1 can be written as 1 over 10, and we have to multiply it. Now this is multiplication of two fractions, right? So how will you perform it? We multiply the numerators together, and then we multiply the denominators together. So this is 1 over actually 100. Okay, this is 1 over 100. What does that tell us? It tells us that since this 100 tells some story to us, it tells us that now we are dealing with or talking about the hundredths place. Hundredths place. And at the hundredths place, you have 1. Okay, since it is 1 over 100, the multiplication of 1 over 10 and 1 over 10 comes 1 over 100. This 100 tells us that I'm telling you a story about hundredths place, and this one is telling you that actually at the hundredths place I'm present there, and there's no tens place, right? It means that there's no tens place. That's why we will write this number as 0, because we don't have any unit point, this decimal point. We don't have any tens place, any number at the tens place, so simply put 0 here. This is at the hundredths place because this is 1 over 100. Therefore, this is actually 0.01. This 1 over 100, this 1 over 100 can be written as 0.01. Let's take the second one. So actually the answer of this 0.1 is actually what? 0.0. This one. For the second one, it is 0.2 multiplied by 0.3. Now, as we did here, this 0.2 tells us what? 0.2 tells us that at the tens place, we have 2. Right? Therefore, we can write it as 2 over 10, as we did in this case. And similarly, 0.3 can be written as 3 over 10. Why? Because at the tens place you have 3. Therefore, if we have to represent this 0.2 multiplied by 0.3 in terms of this fraction number, then this is actually what? 2 over 10 multiplied by 3 over 10. And if you solve it, then this will be 2 times 3 divided by 100. It means that you have 6 over 100. It tells us that, again, this 100 is telling us a story of hundredths place. It's telling you that, hey boss, you know what, it's 100, I'm telling you something about hundredths place. And this 6 is telling you that actually at the hundredths place, I am present there. Since there is only one digit, that is 6, and divide by 100, 100 is telling you about the hundredths place, and there is no any other digit other than 6. It means that we have 0.06. This 6 over 100 can be written as 0.06. As we wrote 0.1 as 1 over 10, similarly we can represent this one in this decimal form. And why it is 0.06? Because 6 is at the hundredths place, but we don't have any other digit that can tell us that what it tells us that at the tens place we have 0. We don't have any other digit, right? So the answer for this one is actually what? Is 0.06. Okay, so this was a simple explanation that when we perform multiplication of two decimals, then the answer that we get and why we get. But let's go a little more deeper into the discussion, and let's dive in a little more deeper, and let's understand this with a pictorial representation. First take this one, 0.1 times 0.1. Okay, so as I told you that this 0.1 can be written as 1 over 10. So if I write it as 1 over 10 times this one as 1 over 10. Now you can see that actually now we are dealing with fraction of a fraction. Remember, we have learned all this in when we are learning about fractions. This is telling you what? 1 over 10 of, that is 1/10 of 1/10, right? So 1/10 of 1/10. It means that if this is a single unit or a whole, and if we focus on this 1/10, right? And if we divide this single whole into 10 equal parts, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, okay? A whole has been divided into 10 equal parts, and you have to take this only one part. That is the fraction 1 over 10, a complete divided into 10 equal parts, and if you have to take only one part, then that will be here. Okay, all these things we have learned in fraction. Now, what does this 1 over 10 tells us? That 1/10 of 1/10. It means that now this 10 tells us that now each of these equal parts has to be further divided into 10 equal parts. You have to take 1/10 of this 1/10. That is, you have to take 1/10 from only this one. If we have to take only 1/10 from this one, it means that first you have to divide all the other parts also into 10 equal parts. Only then you can do that, right? So if we do this, so I'm going to divide, horizontally. If I divide this one into the first part, let's take a little. So this is first division, right? Then second division, then third division, fourth one, fifth one, sixth one, seventh, 8th, and 9 and 10. If not looking very accurately, distributed, just assume that we have actually divided equally. Now you can see that each part, this is one part, two part, third part, fourth part, fifth, and so on, 10th part, 10 equal parts have been further divided into 10 equal parts because of this 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This first part has been divided into 10 parts. Same here, same in this part, same in this part. Okay, you can divide horizontally or even vertically. Even if you would have decided that, okay, this particular part, if I have to divide 10 equal parts, you can go in the form of vertical lines also, right? Not necessarily that you can go in the horizontal way only. Okay, now what does this 1/10 of 1/10 tells us? That now since you have divided this 10 equal parts further into 10 equal parts, because this 10 tells us that, and now you have to take one such part out of it. So if I take one such, this part out of it, this one only, right? This block actually represents what? Now since this whole initially was into 10 equal parts, now it's actually into what? 100 equal parts. Why into 100 equal parts? Because initially we had 10 parts, right? Now we have divided that each part into 10 equal parts. Therefore now we have total 100 equal parts. And what does this single part, that is this block, tells us? It tells us, what fraction does it tell us? It tells us 1/100, right? 100 equal parts, you're taking out this one part out of this 1/10. It means that this single block is representing 1/100. This is the fraction, and this is what, you can write it as 0.01, because it tells us that at the hundredths place we have only one. So this is actually the pictorial representation of this particular discussion that we did here, right? This is the pictorial representation. Let's discuss this one. So this is 0.2 multiplied by 0.3. Now this 0.2 can be written as 2/10, and this 0.3 can be written as 3/10. Now this tells us that, what does it mean? It tells us that you have to take 2/10 of, right, 3/10. That is, first look at this fraction. What does this fraction tells us? 3/10 means what? A whole has been divided into 10 equal parts, and you have to consider 3 parts. So this is first part, this is second part, and this is third part. So this is actually what? 3/10. 10 equal parts, and you are considering 3 parts. Now this 2/10, this is 2/10 of 3/10. It means that now this 10 is telling you that from each part you have to divide 10 equal parts. Now if we are dividing each of these parts into 10 equal parts, it means that whole has to be divided, each and every single part has to be divided into 10 equal parts. Only then we can proceed with the fraction. So same thing what we did here. I'm going to do same thing here. Let's divide it. So this is first one, this is second one, this is third one, this is fourth one, fifth, sixth, seventh, eighth, ninth, and 10th. Not very accurately divided, but again, just think that all these parts are actually equal in size. Okay. Now this 2/10 of 3/10 tells us that now you have divided this 10, tells us you have divided each part into 10 equal parts. Now we have total how many equal parts? We have total 100 equal parts. Okay. Now the fraction is about 100. This 2 tells us that out of each of these 3, take out 2. That is, from these 3 you have to take out 2 from each part. So let's take 1 from this, like this is the first part, right? And this 2 means from 1 this and 1 this. So from the first part you have taken 2 parts. So each part represents what? Each part is representing, this single part is representing 1 over 100, right? So if I take out these 2 parts, it means that this is 2 over 100, right? 1 over 100 plus 1 over 100. So this was from this first part. Now since we have to take 2 parts each of these 3 parts, let's take another 2 parts from this second part. So this one and this one. Again we are taking 2 over 100. The fraction that this and this block will represent is 2 over 100, and this is from this second part. Okay, then again take this and this. Why? Because we have to take 2 from each of these shaded portions. So again 2 over 100, and this is from the third part. Okay, it means that if I have solved this, this will be equal to what? This will be 100. 2 plus 2 plus 2, that is 6 over 100. 6 over 100. You can see that what we got here, 6 over 100, and same thing is actually 6 over 100 is here, right? Now we can write the 6 over 100 as, since we don't have any digit at the tens place, so this is 0.06. 6 is at the hundredths place. Okay, so this was a pictorial representation of these two, I mean this one and this one, were pictorial representation for these two individual multiplications. So my point was to explain you that when we do multiplication of decimals, then what do we mean by actually that? Okay, how to multiply decimal numbers? Let's learn that. If we have two decimal numbers, let's say we have 0.1 multiplied by 0.1. Okay, so if you have to multiply these two numbers, let's begin. Write this 0.1 here and then multiplied by 0.1, same as we do in any other cases. Like whenever we have to multiply, 23 times 38, let's say. So whatever steps you follow, same thing you have to follow here also. Just what you have to do is, for a moment, just forget these decimal numbers. Simply think like you are multiplying only 1 with 1. Okay, just forget this. So if I multiply 1 with 1, you'll get 1. 1 times 0 is 0. Then 0 times 1 is 0. 0 times 0 is 0. So if you add all these, this will be 1 and 0 and 0. Now take this first decimal point. How many digits do we have after decimal point in this decimal number? We have 1 digit, that is 1. How many digits to the right of this decimal point we have in this number? Again we have 1. So 1 plus 1, that is, we have total in these two numbers, we have total 2 digits after the decimal point. 2 digits, 1 here and 1 here. So count from this position, from this, starting from the extreme right digit, 1 and 2, because 2 is a count here. So 1 and 2, just place your decimal point after this number. Okay, so this will be your answer, 0.01. Let's take this one only. If I say that we have to multiply 2.3 and 3.8, okay, just treat it like any other multiplication. 2.3 multiplied by 3.8. Okay, for a moment just forget these two decimal points, forget them. Simply multiply, think that we are multiplying 23 and 38. So 8 times 3 is 24, 2 will be get carried over here, and 8 times 2 is 16 plus 2 is 18, and then 3 times 3 is 9, and 3 times 2 is 6. When you add these, you get 4, 17 here, and 8 here. Okay, now look at this decimal point. How many digits do we have right to this decimal point? We have only one digit. How many digits do we have to the right of this decimal point? We have again 1. So 1 plus 1 is how many? 2 digits. Starting from here, extreme right digit, 1 and 2. Place your decimal after the second, before the second digit. Okay, so 8.74 will be your answer. Okay, let's take a few more. If we have to multiply 1.25 and times 3.78, let's say this one. Okay, so let's write 1.25 multiplied by 3 times 78, 3.78, and then, so forget for a moment this decimal point. 8 times 4 is this 0 here, 4 get carried over here, 8 to 16 plus 4 is 20, 2 get carried over here, 8 times 1 is 8 plus 2, so this is 1000 gone here. 7 times 5 is 35, 3 get carried over, 7 to 14 and 17, 1 carried over here, 7 times 1 is 7 and then 8. 3 times 5 is 15, 3 times 2 is 6 plus 1 is 7, and 3 times 1 is 3. Okay, now you have to add these. 0, 5, 12, 1 got carried over here, 8 plus 1, 9 plus 1, 10, 17, and this is 4. Okay, look at this decimal point. How many digits do we have to the right of this decimal point? 1 and 2, 2 digits in this case. How many digits do we have to the right of this decimal point? 1 and 2 again. So total 4 digits, starting from here, 1, 2, 3 and 4. Just before the 4th digit, place your decimal here. So 4.7250 will be the answer. Let's take one more. If we have 2.7389 multiplied by 0.23. Okay, so write it down here. 2.7389, right? And then multiplied by, this is 0.23, right? So 0, 2, 3 and your decimal here. Okay, 2.7389, then 3, 2 and 0, and this place your decimal here. Just treat like you treat any other multiplication, because had it been like 27389 multiplied by 23, so you write 27389 multiplied by 23, right? Then you would perform it. Same thing here, but only we have decimal here. Let's go. For a moment, forget these two decimal points. 3 times 9 is 27. 2 got carried over here. 3, 8, 24 plus 2 is 26. 2 got carried over here. 3 times 3 is 9 plus 2 is 11. 1 got carried over here. 3 times 7 is 21. Then 22. 2 got carried over here. 8. 2, 9 is 18. 1 carried over here. 2 times 8 is 16 plus 1 is 17. 2 times 3 is 6 plus 1 is 7. 2 times 7 is 14, and 1 got carried over here to 2 to 4 and 5. Then since it is 0, you can leave it because that's of no use, or everything will come 0 only. So then you have to add it. 7, 14, 9, again 9, 12 and 6. Okay, now how many digits do we have to the right of this decimal point? 1, 2, 3 and 4. How many digits do we have to the right of this decimal point? You have 2, so this is 2. 4 plus 2 is 6. Okay, 1, 2, 3, 4, 5 and 6. So you have to place your decimal point just here. Now since you are placing decimal point here, you can put a 0 here. So 0.629947 will be the answer. So this is a way to multiply. What if it was 1 times 0.89? No issues, you can proceed on. Like first you can write this one, so this is 0.89, right, and then multiplied with 1, so this will be 9, 8 and 0. How many digits we have? 2, so point like this. Okay, if it was, let's say, what can we take? Let's make it 10 times 0.89, so 0.89 multiplied with 10, right? So 0 times 9 is 0, 0 8 is 0, 0 is 0, 1 times 9 is 9, 1 times 8 is 8, 1 times 0 is 0. Okay, how many digits do we have to the right of this decimal number? We have 2, right? So 1 and we have 2, so sorry, first we have to add this one, 0, 9, 8 and 0. So 2, starting from here, 1 and 2. Place your decimal point here. So answer will be 0. Since we don't need to write 0 here, this one, so 8.90, or simply you can write it as 8.9, because this 0 tells us that at the hundredths place we have 0 only, so no need to write that. Okay, so this is a way to multiply, perform multiplication involving decimal numbers.